So what if everything we thought we knew about how AI, like ChatGPT, actually writes was just plain wrong? A new paper has just dropped that could seriously upend the entire field. Okay, let's get right into it.
Right out of the gate, the paper hits you with this super bold statement. Stop predicting words one by one. Now, this isn't just some friendly advice. It's a direct challenge to the one fundamental rule that has governed every single large language model for years.
Okay, so here's the core idea, the really big shift. For years, AI has done it the old way, one single word at a time. I mean, imagine trying to write a book by guessing one letter after another. It's slow. The new way this paper is talking about, it's all about predicting entire ideas at once, thinking in whole sentences, not just syllables. To really get why this is such a huge deal, we first have to understand what I'm calling the one word at a time rule. It's this sort of unwritten law that every, and I mean every, large language model you've ever used has been following. Until maybe now.
And that rule has a name. It's called Mech's token prediction. Basically, the AI builds its response sequentially by literally guessing the most likely next word or token again and again and again. You know, the cat sat on the model's entire job is just to guess Matt. That's been the gold standard for years.
But here's the kicker. That simple, foundational rule, well, it turns out it's also AI's single biggest weakness. It's the massive bottleneck that's been holding the entire field back.
And this slide just lays it out perfectly. To write a pretty simple phrase like the efficiency of large language models, the AI has to run a whole prediction cycle for each and every word. First, it predicts the. Then, with that in its memory, it predicts efficiency. You see where this is going, right? It's an incredibly slow, piece-by-piece process.
And yeah, that process, that step-by-step-by-step thing, is exactly why these huge language models are so incredibly slow and just unbelievably expensive to run. Every single word requires a full spin of the computational gears, which burns a massive amount of energy and time. Okay, so we've established the problem. But what if there was a completely new way for AI to think? Well, this new paper introduces a method called CALM, and it's designed to completely shatter that one word at a time rule. CALM, it stands for Continuous Autoregressive Language Models, and it really is a total paradigm shift. Instead of predicting individual words or discrete tokens, it predicts something called continuous next vectors. You can kind of think of a vector as the mathematical fingerprint for a whole idea or a concept, all bundled up into one neat little data point. And I love how the paper puts it here. The model operates on ideas per step, not symbols. This is such a profound change. The AI isn't thinking about the next letter or the next word anymore. It's thinking about the next concept, the next whole chunk of meaning. All right, so this all sounds amazing in theory, right? But the big question is, how on earth do you actually teach an AI to predict entire ideas instead of just single words? Let's dig into the mechanics. Well, it all starts with something pretty simple, just a chunk of text, like this one. The AI's first job is to learn how to take this whole idea and compress it down into a single, super efficient package. The secret sauce here is a piece of technology called an autoencoder. Think of it like a superpowered zip file for ideas. It takes that chunk of text, squishes it down into that single dense data point we called a vector, and then, and this is the really magical part, it can perfectly reconstruct the original text from just that one point. And when I say perfectly, I really mean it. The reconstruction accuracy is over 99.9%. So we're not losing any information when we compress it. It's an incredibly high-fidelity way to represent a whole bunch of words as just one single thing. So here's how it works in practice. CALM will take a chunk of about 4 tokens, or words, and compress them into one single vector. Right away, this cuts down the length of the sequence the AI has to deal with by a factor of 4. It's now modeling language as a series of these idea vectors, not along a clunky chain of individual words. Okay, so the theory's cool, the architecture is clever, but what about the results? Does this thing actually work in the real world? Oh yeah, this isn't just a theory. The performance gains are absolutely massive. And this right here just paints the perfect picture. To generate a 400-word response, a traditional model needs to take 400 separate prediction steps. But with CALM, since it's generating whole chunks of ideas at a time, it only needs about 100 steps. That is a 4x reduction in the amount of work it has to do. And that speed up, it leads directly to huge savings. The paper found that Calm needs 44% less computing power for training to get to the same level of performance as a normal model. I mean, for companies that are spending millions and millions of dollars on training these things, that number is a total game changer. So let's just recap the big wins here. You get faster training and faster responses for the end user. You get way better performance for every dollar you spend on computing power, so more bang for your buck. And as a bonus, it even opens the door to a whole new way of evaluating these models, maybe even replacing some of the old standards. So where does all this leave us? I mean, are we actually looking at the end of an era here? What does this really mean for the future of AI? You have to understand, this is not just some minor tweak. It's a fundamental redesign that just throws out all these old technical roadblocks. It removes some major computational bottlenecks, it gets rid of the limits on how many words an AI can know, and it simplifies the whole generation process. It's like a clean slate for building language models. Which, of course, brings us to the final critical question. This approach fundamentally changes the speed and the economics of AI. So if this technology can scale up successfully, are today's billion-dollar token-based AI models already a thing of the past?